So last week we looked at acids, bases, the pH scale and indicators. And we've got the acids can provide an H plus ion, and this can be used by a base to make water. This means that bases often have the hydroxide ion or the oxide ion in them, because when you put those together with hydrogen, you make water, which is H2O. So it's got H's and O's in it, just like these combinations of ions. So usually when we have an acid and a base, we're talking about the base being a metal hydroxide, so sodium, potassium, magnesium are all the ions of metals with hydroxide, or metal oxides. Calcium, magnesium, lithium are all metal ions with an oxide. So that's what we mean by a base. What we mean by neutralization is that the things that it makes a neutral. I'm trying to use a little bit of color coding to help with this. Of course, acids turn litmus red, bases turn litmus blue, and if we have universal indicator, then that's green when things are neutral. So color coding to help you with this one. All right. So these are just some general equations you need to know. An acid plus a base gives us a thing called a salt and a water and water. And we'll go into that in a little bit more detail in a moment when we look at the salts. So our next bit of teaching. There is a special case, and that's the carbonates and the hydrogen carbonates. They do have the oxygens to give away, but they've also got carbons in there, which means they make a different thing. So if I've got an acid, again, I'm going to use my color red because they turn litmus and universal indicator red, and I add a carbonate, which is a special type of base, and it can be a hydrogen carbonate, so I'll put that in brackets above it. So carbonate or hydrogen carbonate. We still get the same product, but we get one more. So we still get a salt and water. But we also get something bubbling off. So you'll see these ones bubble. And what they're making is carbon dioxide. So it's got an extra product or thing being made. It's still a neutralization. The only difference is this carbon dioxide being given off. So if you have got a carbonate being used, you would say that you'd observe bubbling, which is the experiment today should have bubbling in it. When the bubbling stops, it's finished neutralizing. That's one of the really cool things about using carbonates, is that you can see when they stop neutralizing because they stop bubbling. So the bubbles are gone. We often would use a carbonate to neutralize an acid spill at home, because carbonates are what we call a weaker base than these two, so they're not as damaging to carpets or floors or your skin. So they're things like baking soda and washing powder. So we can put those on an acid spill. When it stops fizzing, we know that it's neutralized because there's no more carbon dioxide being made. So it's all been, the acid's all been used up. There should be some powder left over, which will be our salt. So that in a nutshell is neutralization. An acid plus a base. The base sometimes can be a carbonate. When it's a carbonate, you get the salt and water, but you also get CO2, carbon dioxide. I'll just put that formula there because it is a good one to be able to use rather than writing the word all the time, CO2.